Applications of inequalities. Inequality problems presented as words will require some math translations. So this table just gives us a little head start on some of the translations for the different inequality symbols. So for example, over here on the left we have greater than. So if x was greater than y, we'd call this the greater than symbol if x was greater than y. So common words that represent greater than is greater than or more than, larger than or exceeds. Notice the difference when we have in equals to. So if we have x is greater than or equal to y, well, we could just say that as greater than or equal to, or we could use words like at least. If you need at least 10 computers for a business startup, well, if you have 10, that satisfies the requirement. So that's greater than or equal to. No less than says you need to have the same thing, greater than or equal to. The minimum amount, well, the minimum amount includes that minimum. So I need at minimum $50 for this transaction. Well, $50 is equal to the minimum and it satisfies that condition. And similar words apply for x is less than y, smaller than, has fewer than, is lower than, and for less than or equal to, x is less than or equal to y, at most or is no more than or is the maximum are the types of words that mean less than or equal to. So you might have to use some intuition and logic to translate a situation into an inequality statement, but we're going to see some examples of how to do that so that you don't have to do this all on your own. So we're going to solve the following problems by writing an inequality statement, solving it, and then interpreting the answer. And we're going to start with one that doesn't really have any context. It's just a sentence to get us going. So let's translate and solve. 27 less than x is at least 48. So there's a few elements. First of all, let's identify the parts of this sentence that correspond to parts of an equation. 27 less than x is one part of an equation. So 27 less than x is a subtraction. That would be the same as x minus 27. And then when we say is at least, we're being told about an inequality here. We're being told 27 less than x is at least. So that would mean that it is greater than or equal to at least, and then followed by whatever's on the other side of that at least statement, which is 48. So x minus 27 is greater than or equal to 48. This is our translation of that sentence. Let's go ahead and write that equation out, or that inequality statement, I should say. And now we go about solving this, and to solve this, just as we saw previously, we're just going to isolate for x like we do when we solve an equation with an equal sign. So x is greater than or equal to 48 plus 27. That is 75. So there's not a lot to interpret in a problem which doesn't really have a context to it. So x is greater than or equal to 75 will mean that if x is greater than or equal to 75, this statement is true. 27 less than x is at least 48. Now we're going to jump into a problem that, an inequality problem that has a context to it. It's embedded within a situation. So Dawn won a small grant of $4,000 to buy tablet computers for her classroom, and the tablets she would like to buy cost $254.12 each, including tax and shipping. What is the maximum order or maximum number of tablets that Dawn can buy with her grant? So we want to know the maximum. So to put this together, we need to think about what we're asked to find, which is the number of tablets, the maximum number of tablets. So if she was to buy, say, X tablets, which is our unknown, they would each cost $254.12. So I'll write that as 254.12 times X. And we know that this has to be less than or equal to $4,000 because that's the maximum amount that Dawn has to spend. So that would be less than or equal to $4,000. So we are looking for X, which would tell us the maximum number of tablets. So in this statement, we have an inequality statement that relates X, the number of tablets she could buy, to her constraint, which is a $4,000 budget. So to solve this, we'll just divide each side by $254.12. And then we get that X is less than or equal to, and I'm going to do this one in my calculator because there's no way I'm doing that in my head. And I get that X must be less than or equal to 15.74. I'll round to 2 decimal places. So X must be less than or equal to 15.74. Now, you can't buy a fraction of a tablet computer. So we have to interpret the meaning of this solution. So the maximum number of tablets will have to round down to 15, because if you buy 16, that is not less than or equal to 15.74. So that would put her outside of her budget of $4,000. So the maximum number of tablets is 15 tablets. But what this inequality tells us is that she doesn't have to buy 15 tablets. She could also buy less than 15 tablets. She could buy any number, and then maybe she could use that grant on something else like accessories for the tablets. So that's the point of the inequality, is that it doesn't tell you an exact number. It tells you a range of values that would solve the problem. In this case, we should also recognize that there's also a lower limit, that Dawn has to buy at least 0, or we should say greater than or equal to 0 tablets, because she can't buy a negative number of tablets. So really, after interpreting the context of the problem, she has to buy between 0 and 15 tablets. In our last example, we're going to look at Felicity, who is a small calligraphy business. She charges $2.50 per custom wedding invitation. So that's going to go up and up depending on how many invitations she sells. And given that her monthly expenses are $650, how many invitations does she need to earn a profit of at least $2,800 per month? So we want to know how many invitations per month she needs to write. So the amount of profit that she earns is going to depend on two things. It's going to depend on the dollars she makes, subtract her expenses, and what she wants to know is that she needs to earn at least a profit of at least $2,800. So I'll say her profit, or what she makes minus her expenses, must be at least or greater than or equal to $2,800. So the amount she makes, that's going to depend on how many custom wedding invitations she sells. And she sells them at $2.50 each. So $2.50 times, we will use X to represent the number of invitations that she writes. And she has a fixed monthly expense of $650. And so her maximum profit, or what she makes, subtract the expenses, has to be greater than or equal to 2,800. So here's our equation, which we will now go about solving. So that's our starting equation. Now we're going to go about solving this. So to do that, we're going to isolate x by adding 650 to each side. So we have 2.5 times x is greater than or equal to 2,800 plus 650, which is 3,450. Then we divide each side by 2.5, and we get that x is greater than or equal to 1,380. So Felicity must sell at least, and here's our key word, because she could ideally sell more and make a higher profit, but she must sell at least, or greater than or equal to would be another way to say that, 1,380 invitations to earn the profit that she's seeking.